I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of algebra, looking at the Year 11 standard course, and we're looking at linear relationships, which comes under MSA2. So in this video, we're going to have a look at direct variation. So direct variation, also known as direct proportion, occurs when one variable depends directly on another variable. So for example, the time that you work at your part-time job will directly affect the amount of money that you earn. So one quantity increases or decreases at the same rate as another quantity. So if your hours worked increases, then your pay will increase. If your pay decreases, then that must mean that your time has decreased. So direct variation problems involve a constant of the variation, or something that connects the two variables together. And we call this connection a constant. And it is represented, constant is represented by the letter K. So it is the rate at which the quantities vary. So if, for example, the hourly rate of pay is the constant of variation when determining a person's wage, to solve the problem, you would have to write an equation relating the two variables to calculate the value of K to find the connection between the two. So if we have a look at the blue box, it says, when solving a direct variation problem, write an equation relating to two variables. So we know that we do this by the constant K. That's the rate at which the two variables vary, and it's the connection point. So if Y is directly proportional or directly varied with X, the equation will be Y equals KX. So when we're doing direct variation, we have two variables. One will be Y and one can be X. And we find the constant by creating an equation that looks like this, where K is times or multiplied with X. So the first variable equals K times the second variable. So we solve the equation for K by substituting the values that the question gives us for Y and X. And then what we do is we write a new equation with the solution for K to solve the problem by substituting either X or Y. So what step 3 is saying is that if you were given X and you know your K, then you can sub that and find Y. So Y would equal 2 times 7, so Y would equal 14. So we can use K as a connection point between the two variables to then find more answers to questions relating to that context. So this might be a little bit confusing, but we'll have a look at an example now, and hopefully it all makes sense. And then you can come back to these steps and see what these steps mean. So here we have the cost of a printer varying directly with the speed that it prints the pages per minute. So if the cost increases, then that must mean that the speed that it prints the pages increases too. A printer with a speed of 50 pages per minute costs $700. So there are two variables, the speed and the cost. And we can find the connection between 50 and 700 to then answer other questions. Say if we see on a shelf in the JB Hi-Fi, we see one printer and we see it has a cost of 700, and on the printer it says it prints 50 pages per minute. Then we see a second printer which costs $400, but we don't know however many pages it prints, we can find the connection between these two variables and find the constant k, and use that constant k in the second printer and use it against the cost to then find the pages that this one will print. So hopefully that puts it into a little bit of perspective of what we're doing. But let's have a go at answering question A. Write an equation connecting speed and cost. So we know that our direct variation equation is y equals kx. So if we substitute y and x as speed and cost, then we'll find our k, our equation connecting the two. So we have to figure out which one is which. Is cost y or is cost x? Well, the cost of the printer varies directly with the speed. So the cost varies directly with the speed. And so if something varies directly with, then that goes out the front, and then whatever it varies directly with then goes next to the constant k. So our answer for A is going to be cost equals our constant k times by the speed. Now we've been asked to find the constant k. So we are going to use the values they gave us to find the connection between the two. So if the cost equals k times s, and our cost is 700, equals our k times our speed, which is 50, we can solve this algebraically for k. So we're making k now the subject of our formula, so we can solve for it. So to make k the subject of the formula, we're going to get it by itself, and we're going to do the opposite of anything on this side to take it over to the other side. So if we have times 50, the opposite is divide by 50. So if we divide by 50 on this side, to take it to the other side, we're also going to divide by 50. And that leaves us with 700 on 50 equals k. Then we can solve for k. So k therefore equals 700 divided by 50, and 700 divided by 50 leaves us with 14. So our constant is 14. So then question C says, how much does a printer with a speed of 60 pages per minute cost? So if we write out our formula once again, we know that the speed S is 60 and our constant K to be 14. So we have to find out the cost. So we're trying to find C is 14 times the speed, which is 60. So the cost of a printer with speed of 60 is going to be $840. So as the speed of our printer increases, the cost will increase. So that means that we are doing a direct variation problem that is validated, because as one increases, the other increases. And we can find the constant k between two variables to find the answer for a missing variable. So for example, if we didn't know the cost, but we knew the speed to be 60, we can use our constant to find the cost of that printer. So that's examples of direct variation. And the reason why direct variation is in this linear relationships topic is because if you write out the formula of the gradient intercept formula, where y equals mx plus b, and we write out our formula for direct variation, where y equals kx, we can see similarities. Our m and our k are the same thing. So if we were to graph this direct variation model, our k would be our gradient. So that's why direct variation comes into the linear relationships topic. So you just need to be aware that the k, the constant, can also be our gradient. So if they ever ask you to graph this direct variation problem, Remember, write out your gradient intercept formula, which is y equals mx plus b. Write out your direct variation formula, which is y equals kx. Have a look at the similarities between the two. So y equals mkxx. And we know that whatever is associated with the x is our gradient. So our m is our gradient and our k can be our gradient if we are asked to graph this model of direct variation.